In this video, we want to evaluate the integral of 1 over the square root of 80 plus 8x minus 16x squared. Don't have an obvious U-substitution here, but this looks like an integral we've done before, similar ones, maybe even the last video we did. Let's look at the formulas here. So we have integrals involving inverse trigonometric functions. In the last video, it was the first formula. The integral of anything in the form du over the square root of a squared minus u squared, where a is a constant and u generally will be a function of x. We'll give you the arcsine of u over a plus the constant of integration. We've done some using the second formula, du over a squared plus u squared. That involves the arctangent function. And then the third one involves the arcsecant. So can we put it in form number 1 here? So what we're going to do here is factor out a negative. It's just going to involve completing the square again, just like we did in the several videos. So I'm going to factor out a negative. So this will give us a 16x squared minus 8x. And then the 80 will go over here. Now can I complete the square here? If I put a plus 1 here, this actually will factor into 4x minus 1 quantity squared. Square the first term is 16x squared. Double this product, this is minus 8x. Square the minus 1, I get 1. So this makes just a perfect square this way. But I just can't add a 1 here. And actually I'm adding a negative 1 because I got a minus in front, so this minus multiplies this negative 1, or this positive 1 rather, so it makes it a minus 1. So I'm adding a minus 1, so I have to do the opposite and add a plus 1. So instead of 80 here, this will be 81. Now that's the same thing as what I have in the radicand, just rewritten. Square this out and I'll get the 16x squared minus 8x plus the 1. You distribute the negative and you get that plus 8x and the minus 16x squared. And of course, the minus 1 and 81 getting 80. So that's the same thing. So now I have it in the form that we wanted. It's in the form a squared minus u squared. But what I'm going to do is make my U-substitution so it fits that formula that we looked at. So I'm going to let u equal to 4x minus 1. That's this right here. So the du will be the derivative of that, which will give us 4, and then it'll be a dx. Divide through by 4, and I get dx will equal to du over 4. Now let's go back to the original integral here. This then will equal to the integral. On top we have 1 dx, or just dx. So dx is du over 4. This will be du here. And this 4 over 4, or 1/4. So I'm going to bring the 1/4 out in front. Get 1/4 du. And then we'd have 81. And that's going to be the square root here of 81. I'm looking at this right here, and then also this here. So it's going to be 81 minus this expression written in this form. This is 4x minus 1 squared. But 4x minus 1, that's your u. So this will be u squared. So in the formula, the 81 is the 9 squared. It's a squared minus u squared. So a is going to be 9. And of course u is going to be u here. So based on the formula then, this is going to equal to, the 1/4 is going to be there. So we're just looking at this part right here. And it's going to be, you can use sine inverse, or we can say arcsine of u over a. Now in our case, u is 4x minus 1. This will be 4x minus 1 over the a. In our case, a is 9. and plus the constant of integration. And of course the 1/4. I'd draw here. The final answer then is 1/4 arcsine of 4x minus 1 over 9 plus the constant of integration. Thanks for watching. We'll see you next time.